Today we are starting section 5.6, which is the laws or rules of logarithms, right? These are similar to the laws of exponents we learned. So a logarithm is an inverse operation of a power, right? So the properties of exponents that we worked on are the inverse operations for these laws of logarithms. You should be able to relate. This content was covered in Algebra 2, so it's a review. But again, this is a new lesson for us. So we start off and it says if m and n are positive real numbers and b, the base of the logarithm, is a positive number other than 1, then these 4 rules apply, right? So the first rule we're looking at right here is log base b of m times n. Okay, oops, right here. So things you're going to notice right here, this is m times n. It's a product. It's a multiplication. So we can expand or deconstruct this logarithm into the sum of 2 log terms. And basically, all you really need to do is identify the multiplication inside the argument of the logarithm. Remember, the argument is what's inside the logarithm right here. The multiplication here is going to create an addition here. And you're going to just decompose it to log base b of m, the first factor inside the argument here. Right, so the factor to the left of the multiplication, and then it's plus log base b of n, the factor to the right of the multiplication, right? So this is the first property we're learning. Now this property relates to the properties of exponents right here, right? So in this grouping right here, it's a multiplication. And what you have to remember is that these logarithms right here, this logarithm, the value of that logarithm is technically an exponent. And the value of this logarithm is also an exponent. And what we're doing is technically adding exponents if you view this from an exponential perspective, right? So over here, what we're doing with a and c is we're adding them, right? So that's similar to what's happening here. On the left side of this equal sign here, this is the product of b to the a and b to the c, right? So what you can do is you can think of b to the a right here as the value of m inside this logarithm right here, or the value of m right here in this logarithm. And then b to the c, again, here, b to the c is the value of n here, or the value of n right here. So it really shows up in this group right here when you're multiplying m and n. That's similar to multiplying b to the a and b to the c. And when we do that with exponents, we add the exponents a plus c. Since log base b of m is technically an exponent, log base b of n is technically an exponent, we're adding them. So just trying to relate the properties of exponents here on the right to this property over here with logarithms, okay? Also works with quotients, right? Remember, quotients is division. Divisions are also represented as fractions. So this is log base b of m divided by n. It's a similar property to exponents. When you're dividing with the same base, you subtract the exponents. So in this case, what we're going to do is we're going to deconstruct it or expand it into the difference of 2 logarithms. And what we're going to do is we're going to split the fraction or quotient here by m and n into 2 different groupings of logarithms right here, right? So key thing you need to know is if there's a quotient or a fraction inside the argument of a logarithm, that can be expanded into log base b of m minus log base b of n, right? So fractions, divisions here indicate subtractions here, multiplications here indicate additions here, same base. Rule number 3 is if you have log base b of m equal to log base b of n, right here, right? Then m has to equal n. There's no other way around it, right? That relates to this property right here. When you have a base to an exponent equals the same base to another exponent, if b to the a equals b to the c, then logically a must equal c. It's the only way around it. That's kind of relating this property here. Next, rule number 4. So if we're dealing with a logarithm and the argument of the logarithm contains a power, m to the k, we can take that k exponent and bring it out in front of the logarithm right here, right? And vice versa, right? So, and you'll be doing this in both directions. So if you have an exponent here in the argument, when you can bring it out and make it a coefficient of the logarithm, so it shows up here as k, or if you have k as a coefficient of the logarithm, you can replace it and bring it up here as an exponent for m there. And whoops, excuse me. And that's the property we're studying today. Oops. K is getting messed up. Okay, so those are 4 properties, and then we have these inverse properties we're going to talk about quickly here. So on the left, what you want to focus on here is that this logarithm right here is log base b of b to the a. Now, I introduced this to you already. Anytime you have a logarithm where the base of the logarithm, right, this base right here, is identical to the base in the argument, well, this log simplifies directly to the exponent a, right? So that's one inverse property here. The justification for this actually uses property number 4 right up here. So I can technically take this a exponent and bring it out in front if I want to, right? So if I did that, then I'm down here in this green expression, right? So now you have a times log base b of b to the first here, right? Now, the value of this log base b of b to the first, that logarithm is equal to 1, right? If you think about it right here in red, this is really saying base b raised to what exponent is b, right? That exponent has to be 1. So the value of this logarithm right here must equal 1. A times 1 is a. Therefore, this expression right here must equal a, right? Now, this can go in the opposite direction as well, right? So in the first one, it was log base b of b to the a. And then over here, we can write it in the exponential format. If you have a base b raised to a log in the same base, right? So again, the base of this power is the same as the base of the logarithm that is actually in the exponent. Then this will simplify to just a, right? The reasoning is if I convert this logarithmic expression here into an exponential expression, first it's, start with an empty logarithm, right? And we take the base of the power here, and that's going to be right here. So log base b, and then think about the conversion, right? So this is b to what exponent is this, right? So the exponent at hand right now is right here. So that is going to become log base b of, oops, this whole thing is messed up. Oops. This is all moving up here. Excuse me. And so b to the log base b of a must equal a. And that's kind of what we're looking at here, right? It's a little bit harder to make sense of it in this case, but the key thing here is if you have a power where the base of the power is the same base as the logarithm, which is the exponent right now, then this is going to simplify straight to just a, the value inside the argument. Right? So those are our log properties, and we'll get into some examples.